Hello everyone, and welcome to today's presentation. I'm excited to share with you our work on fraud detection in online transactions using machine learning. This is the first of 9 slides, and I'll give you a brief overview of what we will cover. We'll explore how machine learning can help identify fraudulent activities, discuss the methods we used, and look at some results and insights. So let's get started. Online transaction fraud is rapidly increasing, and this trend is something we need to pay close attention to. While it's true that fraud cases are extremely rare compared to genuine transactions, the impact of those fraudulent activities can be quite significant. Traditional rule-based systems, which rely on predefined patterns, often fail to detect evolving fraud techniques. As fraudsters get more sophisticated, these static systems struggle to keep up. Manual fraud detection, on the other hand, is not only inefficient but also prone to errors. It's a slow process that can't scale effectively to handle the increasing volume of transactions. All of these points highlight a core problem. Our current methods are inadequate in combating the sophisticated, ever-changing nature of online transaction fraud. This sets the stage for us to explore more advanced, adaptive solutions. Let's talk about why fraud detection is so important. First, it helps prevent financial loss, which is crucial for both businesses and customers. When fraudulent activities are caught early, we avoid significant monetary damages. Second, it protects customers and businesses from potential harm, ensuring everyone's personal and financial information stays safe. This, in turn, builds confidence in online payment systems. If people trust these systems, they're more likely to use them regularly. Third, maintaining trust is essential for the growth and stability of digital commerce. And finally, effective fraud detection reduces regulatory and legal risks. Companies can avoid penalties and legal issues that come with data breaches or fraud. All these points highlight that fraud detection isn't just about stopping bad actors. It's about safeguarding the entire ecosystem, which aligns perfectly with our overall goal of creating secure and reliable online payment environments. Let's talk about why machine learning is such a game changer in fraud detection. First, it learns hidden patterns from transaction data that might not be immediately obvious to humans or traditional systems. This means it can uncover subtle signals indicating suspicious activity. Second, machine learning handles large-scale datasets efficiently, allowing it to process millions of transactions quickly and accurately. This scalability is essential as transaction volumes continue to grow. Third, it can adapt to new fraud techniques as they emerge, constantly updating its understanding without needing manual reprogramming. This adaptability keeps us one step ahead of fraudsters. Lastly, machine learning outperforms traditional rule-based systems, which rely on fixed rules that can easily be bypassed. Overall, these capabilities make machine learning a powerful tool in our fight against fraud, aligning perfectly with our goal of building smarter, more responsive security systems. Now, let's talk about how we can develop an effective machine learning-based fraud detection system. First, we want to apply and compare multiple ML algorithms to see which ones perform best in identifying fraudulent activities. It's important to test different models because each algorithm has its strengths and weaknesses, and comparing them helps us choose the most accurate one. Next, handling class imbalance is a crucial part of this process. Fraud cases are typically much rarer than legitimate ones, which can make modeling tricky. That's where SMOTE comes in. It helps us balance the dataset by creating synthetic examples of the minority class, ensuring our model doesn't just learn to predict the majority class all the time. Finally, evaluating the performance of our system is essential. We'll use standard metrics like accuracy, precision, recall, and F1 score to get a comprehensive view of how well our fraud detection model is working. This step ensures that our system isn't just accurate overall, but is also effective at catching actual frauds without raising too many false alarms. Altogether, these steps are key to building a robust fraud detection system that can adapt and improve over time. Now, let's take a closer look at some of the machine learning models we've used. Starting with Support Vector Machine, or SVM, which is a powerful classifier that works by finding the best boundary, or hyperplane, that separates different classes in the data. It's especially effective when the data is complex and not linearly separable. Next up is k-nearest neighbors, or KNN. This is a simple yet intuitive algorithm that classifies new data points based on the labels of their closest neighbors. It relies on the idea that similar data points tend to be near each other, making it quite effective for certain types of problems. Then we have random forest and decision trees. Decision trees make splits based on feature values to classify data, and they're easy to interpret. Random forest builds multiple decision trees and combines their predictions, which usually results in higher accuracy and better robustness against overfitting. Moving on to naive Bayes, LDA, QDA, and neural networks. Naive Bayes is based on probability and makes strong assumptions about feature independence, but it often performs surprisingly well. LDA and QDA are linear and quadratic discriminant analysis methods, respectively, which are great for modeling class distributions. And neural networks, inspired by the human brain, are highly flexible models capable of capturing complex patterns in large datasets. All these models serve as essential tools in our machine learning toolkit, each with its own strengths and ideal use cases. By understanding their core principles, we can better select the right model for each specific problem, helping us achieve more accurate and reliable results in our overall analysis. Now, let's dive into the core components of our fraud detection system. First, we have the fraud and non-fraud prediction. Here, our goal is to accurately distinguish between legitimate and fraudulent transactions, which is crucial for minimizing financial losses and maintaining trust. Next, we utilize machine learning models. These models learn from historical transaction data to identify patterns that indicate fraud. Their ability to adapt and improve over time makes them powerful tools in our arsenal. To address the challenge of class imbalance, since fraudulent transactions are relatively rare, we employ SMOTE, or synthetic minority oversampling technique. This helps us create a more balanced dataset, ensuring our models don't become biased toward the majority class. Data preprocessing is also a vital step. It involves cleaning, transforming, and encoding our raw transaction data to make it suitable for modeling. Proper preprocessing significantly enhances model performance and reliability. All of this operates on transaction data, which includes details like transaction amount, location, time, and other relevant features. The quality and richness of this data are fundamental to our system's success. Finally, this all fits within our system overview, which integrates these components into a cohesive pipeline. By understanding each part and how they connect, we can build a robust fraud detection system that effectively safeguards transactions and improves over time. Now, let's move on to the final slide of this series. Here, we see an overview of what we've covered so far. First, we looked into the dataset description and performed exploratory data analysis to understand the data's structure and key patterns. Then, we focused on data preprocessing and feature engineering, which are crucial steps to prepare the data for modeling and improve performance. Next, we trained our models and evaluated their effectiveness, making sure we're on the right track. The results, along with our conclusions and a final demo, tie everything together and showcase what we've achieved. Lastly, I want to highlight that there are upcoming videos in this series, so stay tuned for more deep dives and advanced topics. This slide really encapsulates the journey we've taken, from understanding the data to delivering actionable insights and future learning opportunities. If you found this video useful, please give it a like. Your support helps us reach more people interested in machine learning. Feel free to comment with any questions you have. I'm happy to clarify or discuss any part of the project. And don't forget to subscribe for the full series on machine learning projects, so you won't miss out on upcoming content. Thank you so much for watching and engaging. I appreciate your time and interest in this topic.